Imagine a data center so massive that powering it requires an entire new energy system. Not a few backup generators, not a larger connection to the local grid. An entire network of new power generation, transmission infrastructure, and industrial facilities, all built to feed one of the world's biggest artificial intelligence projects. And now, in southern Ohio, that's exactly what is taking shape. OpenAI has agreed to lease computing capacity at a massive new campus in Pike County, Ohio, where the first phase is expected to come online in 2028. At full scale, OpenAI plans to secure as much as 8 gigawatts of computing capacity here. But the really surprising part isn't the number of computers. It's everything that has to be built around them. Because the future of artificial intelligence is becoming a construction problem. And Ohio may be one of the clearest examples of what that future looks like. The project is called the PORTS-Pike Technology Campus. It's being developed by SB Energy, a company backed by SoftBank, on and around the former Portsmouth site in Pike County, Ohio. For decades, this region was associated with uranium enrichment and America's nuclear program. Now, the same industrial landscape is being transformed for a completely different strategic purpose: artificial intelligence. The plan is enormous. The broader development is designed around roughly 10 gigawatts of data center and power infrastructure. OpenAI has now signed a 20-year lease for as much as 8 gigawatts of computing capacity at the site. The first phase is expected to deliver around 800 megawatts in 2028, while the full build-out is planned to continue into the early 2030s. To understand how extreme that is, consider this. 1 gigawatt is roughly the average electricity consumption of hundreds of thousands of American homes. So we're not talking about a normal technology facility. We're talking about an industrial-scale energy consumer. Why does AI need this much power? To understand why OpenAI needs something this large, we have to look at what is happening inside modern AI systems. Every time a powerful AI model is trained, billions of calculations have to be performed across enormous numbers of specialized processors. And once those models are deployed, millions of people and businesses can use them simultaneously. That means AI requires computing power at a scale that traditional software companies never needed before. The computer itself is only one part of the equation. You need the chips. You need servers. You need networking equipment. You need cooling. You need buildings capable of holding thousands upon thousands of machines. And above all, you need electricity. Lots of it. That is why the AI race is increasingly turning into a race for physical infrastructure. The companies that can secure enough land, electricity, chips, cooling capacity, and construction capacity may have a major advantage over the companies that cannot. And that's exactly where this Ohio project becomes interesting. An entire power system. The data center cannot simply plug into the existing electricity network and start running. The surrounding energy infrastructure has to expand with it. According to the U.S. government, SB Energy plans to develop up to 10 gigawatts of new power generation to support the project. And around 9.2 gigawatts of that planned generation is expected to come from natural gas. That's an extraordinary amount of new generation for a single industrial development. But there's another piece. The electricity also needs a way to move around the region. So SB Energy and AEP Ohio are planning roughly $4.2 billion in new and upgraded transmission infrastructure. That means substations, transmission lines, grid connections, and the supporting infrastructure required to move enormous amounts of electricity from power plants to computing facilities. In other words, the AI data center is only one part of the mega project. The real project is an entire ecosystem built around it. And this is where the story gets even more unusual. Nvidia isn't simply supplying chips to the project. The company has agreed to invest $1.5 billion in SB Energy. It will also provide up to $105 billion in guarantees connected to the Ohio data center arrangement. That number sounds like the cost of the project. It isn't. The $105 billion figure represents potential guarantees and financial support tied to the infrastructure, lease, and power arrangements. But the scale of the commitment shows something important. Nvidia is betting that demand for AI computing will remain enormous for years, and it has a direct reason to make sure the infrastructure exists. Because Nvidia's chips are at the center of the AI computing boom. At this Ohio facility, Nvidia is expected to be the exclusive chip supplier. So the relationship becomes incredibly interconnected. OpenAI needs computing capacity. SB Energy builds and operates the infrastructure. Nvidia supplies the computing hardware and supports the infrastructure financing. And the entire system is being built around the expectation that demand for AI will continue exploding. The old site is getting a new purpose. Perhaps the most fascinating part of this project is where it's happening. The campus is being developed near the former Portsmouth gaseous diffusion plant. That site was once part of America's nuclear industrial complex. Today, the region is being repositioned as an advanced technology and energy hub. It's a remarkable transformation. A place once dedicated to one of the most strategically important technologies of the 20th century is being prepared for one of the most strategically important technologies of the 21st. And this isn't happening in isolation. Other nuclear, energy, and industrial projects are also moving into the surrounding region. That means the real story isn't just about OpenAI. It's about the industrial redevelopment of southern Ohio. Projects of this size don't just require computers. They require people. OpenAI says the development is expected to create around 35,000 construction jobs through 2032. Once operational, the campus is expected to support around 2,500 long-term jobs. That means electricians, engineers, construction workers, equipment operators, power specialists, data center technicians, security personnel, and thousands of workers across the supply chain. This is one of the reasons governments are increasingly competing to attract AI infrastructure. A giant data center can become an anchor for an entire regional economy. But it also creates a difficult question. Who ultimately pays for the infrastructure? The power question. AI data centers are appearing at exactly the same time that electricity demand is beginning to rise rapidly. For decades, efficiency improvements helped keep electricity demand relatively stable in many parts of the United States. AI is changing that equation. Training increasingly powerful models and operating them at global scale requires enormous computing resources, and computing resources require electricity. That's why some of the biggest AI infrastructure projects are now being built alongside new power plants. The Ohio project is one example. And if this model spreads, future technology hubs may increasingly look less like traditional office campuses and more like industrial cities. Data centers on one side, power plants on another, transmission lines connecting everything, and massive cooling and networking systems running continuously in the background. The cloud is becoming physical. But there's a problem. Building something this large is not easy. A project can have billions of dollars behind it and still face problems with permits, construction, turbines, transmission equipment, supply chains, and electricity availability. The power plant itself requires enormous amounts of equipment. The transmission system needs approvals and construction. The data center buildings have to be completed, and the computing hardware has to arrive as the infrastructure comes online. The timeline therefore matters. The first 800 megawatts are expected in 2028. The larger build-out continues toward 2032. That means this isn't a switch that gets flipped overnight. It is a multi-year industrial construction program, and every additional gigawatt adds another layer of complexity. The bigger bet. But perhaps the most important question isn't whether Ohio can build this campus. It's whether the world will actually need this much AI computing. OpenAI is betting yes. Nvidia is betting yes. SoftBank is betting yes. And billions of dollars of infrastructure investment are being positioned around that assumption. If AI demand continues to explode, these facilities could become some of the most important pieces of digital infrastructure on Earth. But if demand grows slower than expected, the economics become much more complicated. That's the risk behind the entire AI infrastructure boom. These companies aren't just building today's computing capacity. They're building for the AI demand they expect several years from now. This changes what a data center means. For most people, a data center is just a building full of servers. But projects like PORTS-Pike are changing that definition. A future AI data center can require power plants, transmission networks, industrial cooling, massive buildings, specialized chips, high-speed networking, and thousands of workers. At this scale, a data center begins to look less like a building and more like a city-sized industrial machine. And that's the real significance of what is happening in Ohio. For years, the AI revolution looked almost entirely digital. We talked about models, algorithms, chatbots, robots, and artificial intelligence. But behind every one of those systems is something much more basic: electricity, steel, concrete, land, machines, and people. The next phase of the AI race may therefore not be decided only inside research labs. It may be decided by who can build the biggest infrastructure, who can secure the most electricity, who can get the most advanced chips, and who can construct these enormous computing factories fast enough. In southern Ohio, an old industrial site is being transformed into one of those factories. And if the project reaches its full potential, up to 8 gigawatts of AI computing capacity will operate here. That's not just another data center. It's a glimpse of what the physical infrastructure of the AI age could look like. The future of AI isn't floating somewhere in the cloud. It's being built 1 gigawatt at a time. And this is only the beginning.